Hello everyone, welcome to my channel Indian School of Physics. This is Nitin here, and today I have come up with the JEE Advanced 2020 solutions. So here is the discussion of paper 1, and it's a review of paper 1. I am going to tell you about what I felt about this paper while solving it. So let's start with the questions. Today I'll be speaking in Hindi as well, because many people are Hindi bhashi also. So here is the first part of this paper. ये क्वेश्चन नंबर 1 है यार, और इसकी मार्किंग स्कीम जो है +3 -1 है. सो क्वेश्चन नंबर 1, a football of radius r is kept on a hole of radius r less than capital R made on a plank kept horizontally. One end of the plank is now lifted so that it gets tilted, making an angle of theta from the horizontal as shown in the figure. The maximum value of theta so that the football does not start rolling down the plank satisfies. And so idhar ye diagram is given. So this sphere is kept in this gap, and the size of this gap is given. It's a circular hole present here. Its diameter is 2r. So we have to find out the condition, the maximum value of theta, so that it doesn't roll over it. Okay, so let's discuss this. So it's a relatively simple problem compared to other problems in the paper. So when we are going to increase this angle theta, the line of action of this mg will start changing its direction, and at one point here you'll find that this normal reaction and mg will be in along this line. Normal will be always passing through the center of it, and ये जो mg है, this will be acting vertically down here. The moment line of action of mg comes this side, mg will allow this ball to roll over it, and if it is towards the left, it will be staying in equilibrium. So this is the logic here. So let's say at some particular angle theta, this line of action of mg is just passing over this edge, and normal is acting in vertical direction. I haven't drawn it yet, but I think it's very obvious, you can understand. So now this angle is theta, this is 90 minus theta, this angle is 90 minus theta, and this angle is theta. So I can say that particular angle theta max is nothing but small r by capital R sine theta. So this is going to be the answer of first problem. And my view of this problem is, it's a standard JEE advanced type question and slightly on the easier side. Its answer is A. Let's move to the next part of second question here. It's a very nice question. A light disc made of an aluminium, so it's a conductor and it's a non-magnetic material. It is kept horizontally and free to rotate about its axis as shown in the figure. A strong magnet is held vertically at a point above the disc away from its axis. On revolving the magnet about the axis of the disc will, there are 4 options given. And so let's I'll not go to the options now. I'll just tell you what is happening here. So this is the magnet kept here, and now magnet is rotating around this disc, and if you see, it's made of aluminium, so it's a conductor, and at the same time it is non-magnetic material. So let's see what is going to happen here. If you see the top view of this disc, so this magnet must be creating some magnetic field in certain region. I am taking that region as circle. It more or less it will be circular only. And when I'm rotating it along the disc, so earlier through this circular region where field was present earlier, in this region this flux was constant, it was not changing. But the moment this magnet will start moving, in this light green part or this circular part, the flux value will start changing, it will start decreasing. So tendency of this part will be to increase this flux, whereas in the remaining disc, earlier this flux was 0 in the remaining part, and the moment this magnet will start moving from the blue part of the disc, you will find the flux starts increasing. So tendency of these two parts will be to maintain the flux. In order to maintain that, the disk will start rotating in the same direction as magnet, and reason for that is it will reduce the flux through blue part, and it will try to increase the flux through this green part, a small circular area. So what is going to happen actually in this case, the disk will start rotating in the same direction as a magnet, and you can say due to changing flux here, the eddy currents are going to develop, and which will cause the heat generation in the disk, and due to which temperature of disk should also increase. So if you choose the answers here, the correct answer is B part here. The disk will rotate in the same direction as the direction of magnet's motion. And my view of this problem is it's a very good problem. It's a good conceptual problem where many good students can also mistake. I think those who are watching this video will realize it. And if you are one of them who has made mistake in this, please leave your comment in the videos. So it's a typical JEE Advance problem. Without calculation, you can solve this question. Next. Now, a small roller of diameter 20 centimeter has an axle of diameter 10 centimeter. It is on a horizontal floor, and a meter scale is positioned horizontally on its axle, with one edge of the scale on top of axle. So here this scale is placed. The scale is now pushed slowly on the axle so that it moves without slipping on the axle, and the roller starts rolling without slipping. After the roller has moved 50 centimeter, the position of scale will look like. ये भी एक बहुत अच्छा क्वेश्चन है बच्चों. इसमें बहुत लोगों ने मिस्टेक किया होगा, ऐसा मेरा फीलिंग है. आई हैव दैट फील, बट इट्स ए रिलेटिवली ईजियर प्रॉब्लम, बट वेरी हाई प्रोबेबिलिटी ऑफ मेकिंग मिस्टेक. तो आइए देखते हैं क्या हो रहा है इसमें. इफ़ यू सी in the beginning, when this disk is moving a distance of 50 centimeters, so since rolling is happening, pure rolling is happening, so if it was moving with the speed of VCM, and there was some omega, so first thing I can write for this point, if there is no slipping, ये VCM जो है वो 2R omega होगा. It is going to be equal to 2R omega. Now when we are pushing this scale, there is no slipping at this point, so scale velocity is VCM plus R omega. Bigger radius I'm taking as 2R, that's why VCM is 2R omega, and here VCM plus R omega, this value is the velocity of topmost point, and since there is no slipping, this is going to be the speed of scale also. So which comes as, if R omega as VCM by 2, if you substitute, this comes as 3 VCM by 2. So the displacement of this point here, you can say its absolute velocity is known to us. Here it is 3 by 2 times of VCM. So the distance center of mass is traveling in certain time, I can write it as VCM dt. That comes as 50 centimeter with respect to ground. Similarly, I can write for this point P, the total distance traveled by will be integral Vp dt, which comes as 3 by 2 into 50, which is 75. These two values are with respect to ground. But if you see here in the question, they are asking with respect to disk, what will be the position of this scale. So many people would have marked this answer, which is wrong actually. So let's see here. After some time, when we look at the rod has moved distance of 75, but this roller also has come forward by 50 centimeter. So the length which rod will cross, or the scale will cross with respect to roller, is going to be 25 centimeter only, and the scale will look somewhat like this, which is option B. This is going to be the right answer for this problem. And if you see, it's an easy and very beautiful problem. You need to be very, very careful while writing your answers, and there is a very high probability that some students would have marked option C. If you are one of them who has marked option C, please write your comments. Let's move to the next problem. A circular coil of radius r and n turns has negligible resistance, and its two ends are connected to two wires, and it is hanging by those wires with its plane being vertical. The wires are connected to a capacitor with a charge Q through a switch. the coil is in a horizontal uniform magnetic field B naught parallel to the plane of the coil. Alright, so it is in the plane of the coil. That means here, when the switch is closed, the capacitor gets discharged through the coil in a very short time. By the time capacitor is discharged fully, the magnitude of angular momentum gained by the coil will be. And assume that the discharge time is so short that the coil is hardly rotated during this time. Means orientation is almost similar. It's a very d theta angle it will rotate, but by that time some angular momentum would have gained by this coil. That is what we have to calculate here. So it's a very simple problem. You can see when this discharge is happening, when this switch is closed, I can write the current which is flowing through the circuit capacitor to the coil. I can write it as dq by dt, and as current is passing through this coil will behave like a current carrying loop placed in magnetic field. So there is going to be some torque acting on it. That torque is given by mu cross B. I can write its magnetic moment, that is number of turns, I pi r square. B, initially this mu is pointing outward or inward depending on from which side this charge is coming. So angle is 90 degree. So this is the magnitude of this torque here. And now I value I can write as dq by dt. So if you see clearly, if I bring this dt this side, it is going to be tau dt. Tau dt is nothing but angular impulse, which is equal to change in angular momentum. When I do that, you will be getting answer as pi n q b r square. So this is going to be the answer. Option C is the option B is the right answer here. Option B, let me correct it. Option B is the right answer for it. Okay, so it's a easy and very standard problem of magnetics. Let's move to the next problem. And here a parallel beam of light strikes a piece of transparent glass having cross section as shown in the figure. Correct shape of emergent wavefront will be. Figures are not drawn to the scale. So it's a very conceptual problem, and those who are my regular students, they would have realized that very recently we had a discussion on the shape of wavefronts in wave optics class. So those who want, they can look for special classes of wave optics. It's free of cost. So all you need is just log into Unacademy and check that classes. It's a special free course basically. So here it is. If you see here, this part of the glass is thick, and this is thin, and this is again thick. So it is somewhat like this portion will have a property of convex lens, this will have property of concave lens, and this will be somewhat similar to convex lens again. So here, when I try to use these properties, convex lens will be a converging lens, this will be a diverging part, and this will be again converging. So you can see here this parallel beam of light, in the upper part it is going to converge to some point. So this is how this wavefronts will develop here. Here I have shown it. These wavefronts are going to be perpendicular to light rays, and for diverging, these wavefronts are going to be somewhat similar to this. So in this part, these wavefronts are in this manner. Here again converging beam, so it is going to be somewhat like this. When we combine it, the rough shape of these wavefronts will be somewhat like this, which is in the option A. So option A is the right answer for this question. And my view about this problem, it's a very good conceptual problem on Huygens principle, and it's slightly tricky and a moderate level problem, but not many students would be able to solve this. Question number 6. An open-ended U-tube of uniform cross-section area contains water. Initially, the water level stands at 0.29 meter from the bottom of each arm. Kerosene oil, water immiscible liquid of density is given, is added to the left arm until its length is 0.1 meter as shown in the diagram. The ratio H1 by H2 of the liquid in the two arms is. So it's a standard problem, slightly on the easier side, I feel. So you can see here, after you put this kerosene in the tube, the liquid level, this light blue liquid level, will come down. Initially both sides this liquid level is going to be at the same level, but when we are keeping this kerosene here, this liquid level will come down. So a situation like this will arise, and here this length is given as 0.1, and total length is given as h1, and this length is given as h2. So we have to find ratio of h1 is to h2. So very easily I can say, I can equate the pressure here and here, or maybe I can use this point and this point also. So however, for solving purpose, I have used these 2 points. Pressure are going to be equal. So, and you can ignore the atmospheric pressure in such problems. So directly I can write rho kerosene into width, that is 0.1 into G, plus rho water into H1 minus 0.1 into G. This is the pressure here, and that must be equal to pressure from other side, which is rho water into H2 into G. This is equation number 1 for me. If I simplify, I get H1 minus H2 at 0.02. Now I can use conservation of volume for this water. So initially this water was 0.29 is given in each part. I can ignore this middle one. So initial volume is area into 0.21, 0.29, and both sides, so double of it. Area gets cancelled, so we can deal in terms of length itself. So now the new volume is H2. So this H2 and this length is H1 minus 0.1. So H1 minus 0.1 into area, H2 into area, that should be equal to area into 0.29 plus area into 0.29. When I do that, I simplify, I'll be getting H1 plus H2 as 0.68. When I simplify this, I am getting H1 H2 values, and I'll be getting 35 by 33, that is option B. So it's a moderate difficulty level problem, quite common in standard textbook also. You would have seen such type of questions earlier also. This is solvable by a majority of the students. Next part, section 2 here. It's multi-choice, multi-correct. Relatively, it was not very tough compared to earlier. Some of the questions were solvable at least. And the last part where numericals are there, they are also somewhat easy, I have felt. Few questions are really tough. So next, 7th question. A particle of mass m moves in a circular orbit with potential energy V is equal to Fr, where F is positive constant and R is its distance from the origin. Its energies are calculated using Bohr model. If the radius of the particle's orbit is denoted by R and its speed and energy are denoted by V and E respectively, then for nth orbit, so we have to apply Bohr model in a modified potential energy form. So such type of questions have been part of JEE exam earlier also. It's a very standard problem. So potential energy is given. I can write F is equal to minus du by dr. So that force only is going to provide the centripetal acceleration. So I can write magnitude of that force F is equal to mv square by r, and quantization formula I can use mvr, angular momentum, is nh by 2 pi. When I simplify this, I can get r value and v value. So I am getting one answer as r is proportional to 2 by 3 and v is proportional to n by 3, n to the power 1 by 3. So that is corresponding to option B. Similarly, I can write total energy of this particle. So half mv square plus potential energy Fr is given. If I substitute the value of V here, I'll be getting this answer as 3 by 2 n square h square f square by 4 pi square m to the power 1 by 3. So this question, this is option C. So B and C are the right answer for this question, and I'll keep this question in moderate level. And standard problem of modified Bohr model has been asked in JEE Advanced multiple time in similar manner, that potential function will change and they will ask you to apply Bohr model into that. Next, this problem. The filament of a light bulb has surface area of 64 millimeter square. The filament can be considered as a black body at temperature 2500 Kelvin, emitting radiation like a point source when viewed from far. At night, the light bulb is observed from a distance of 100 meter. Assume the pupil of eyes of the observer to be circular with radius of 3 millimeter. Then some values are given, and they're asking us power radiated by the filament in the range of radiated power entering into eyes of the observer is in the range of the wavelength corresponding to the maximum intensity of light is this. Taking the average wavelength of emitted radiation as 1714 nanometer, the total number of photons entering per second into one eye of the observer is in the range of. So luckily in this question they have given range, but still it's a calculative problem. Conceptually it's a very simple, straightforward problem, but the calculations make it tough. So here is the situation. This is the light bulb which we can treat as a point source. So it will be radiating energy in all possible direction, and we can treat this as a black body. So I can say the energy emitted per second by this is sigma EA t to the power 4. When I apply it and substitute the values, I get answer roughly close to 141.8. But if you see the power of filament, the option which is given is 642, so it's far away. So A should not be my answer. Then power entering into one side. So this source P is given. So you can see these wavefronts are going to move, spherical wavefronts. So at a distance of x, the intensity of emitted rays will become P divided by 4 pi x square, because we are treating it as point source, times area of this. So that will be the energy received by this eye per second, or you can say it is radiated power received by the eye. So AE, and where RE value is given. So if you substitute these values, this answer roughly comes close to 3.19 into 10 to the power minus 8. When you check options, luckily it matches, it falls into this range. So B is my answer in this case. Next part, the wavelength of corresponding to maximum intensity of light. So here if you see the temperature of black body is given. So maximum wavelength you can calculate by using Wien's displacement law, which is nothing but lambda m into T is equal to B. B is given and T is given, so we can find out this lambda maximum, which comes as 1160 nanometer. I'm not showing the calculation, that is the worst part of this problem. And next they are asking us number of photons. So this is BC is also my answer. They told average wavelength of radiation is approximately 70 in 40 nanometer, number of photons. So I can say here that this power which is entering into human eye, that I can write as n into hc by lambda. All right, energy per unit area basically I'm writing, and that value is nothing but hc by lambda is energy of one photon into number of photons divided by T. So this n by T value I have to find out, and it comes as if you substitute 2.8 into 10 to the power 11. So if you see, that also comes into the same range. So I'll be accepting this as my answer. PCD is the answer. It's a moderate level question with a very lengthy calculations, makes it a tough problem for the time it requires for solving. Alright, so I'll keep this problem in the tough zone just because of the calculations involved in this. Now question number 9, sometimes it is convenient to construct a system of units so that all the quantities can be expressed in terms of only one physical quantity. In one such system, dimensions of different quantities are given in terms of quantity x as follows. Some relations are given here for position, speed, acceleration, and linear momentum and force. Then they are giving us different options here. So easiest way of solving this question is, I'm just writing here length is x to the power alpha, L by t velocity, L by t square acceleration, ml t power minus 1, this is momentum, ml by t square, that is force. So here if you see in the left part, it is alpha plus p. I can get alpha plus p by adding these two, multiplying these two here. So it will become L square by T square, which is nothing but velocity square. So I can very easily, I can say that 2 beta is equal to alpha plus p, that is option A. Similarly, I can check for this part, p plus q minus r. So p plus q and minus r. All right, I have to write p plus q minus r here. So just multiply these and these three terms. When you do that, you will be getting here, or this was simple to check, you can easily do that. So you will be getting here, when we multiply, if you see this here, x to the power beta by t, I'm just substituting here this L by t value, I'm substituting here. So I'm getting this t value. When I include this, I'm going to get b is equal to p plus q minus r. This way it is slightly tough to check these options. The easier way, however, will be, if you see here, I'll check in the next part, p plus q plus r. So I'm just multiplying those quantities here. So L by t square, ml by t, ml by t square. When I do that, I don't get any option other side. So D is wrong. Similarly, I can check for p plus r minus q. So x to the power p multiplied by x to the power r divided by x to the power q. When I do that, I am getting some unknown number. So D is also not my answer. So correct answers are A and B. And it's a moderately difficult problem. Though I'll still call it on the easier side. It's difficult because some people may find this type of approach for solving it, and that makes it a time consuming problem. However, if you are going by this logic, very quickly you can check all the options and you can get the full credit for this problem. Next one. A uniform electric field is applied in a region. A charged particle of mass m carrying positive charge q is projected in the region with initial velocity of values given. This particle is aimed to hit a target t, which is 5 meters away from its entry point into the field as shown. Q by m ratio is given. So 4 options are given. The particle will hit if projected at an angle of 45. T will hit if projected at 30 or 60. Time taken. So here range formula I can use, and the easier part here is, since it is uniform electric field, it will be somewhat similar to standard parabola equation or projectile motion, you can say, where G will be replaced by QE by M. So all I have to do is just replace this G with QE by M. When I do that and substitute these values, I'm not explaining the calculation part here, it's simple. So I'll be getting this sine 2 theta as root 3 by 2. So which gives me the two values, theta as pi by 6 and pi by 3. So when I do that, I'm going to, once I know these angles, I can calculate the time. Time is 2 v naught sine theta by g. Again, when I simplify, then I'm getting in this form, this time, root of 10 by 3 sine theta 10 to the power minus 6. Now theta has these two values, so sine theta will be either half or root 3 by 2. When I do that and substitute here, so this is one answer, by the way, which is option B. So I'm going to get these two answers for time, which matches with option C. So here I can say B and C is the right answer for this problem, and I can say my view of this problem is conceptually moderate, but some calculation make it slightly time consuming problem. But overall it is doable problem in the exam. You must not miss marks in such problems. The next one. Question number 11. Shown in the figure is a semicircular metallic strip that has thickness T and resistivity rho. Its inner radius is R1 and outer radius is R2. If a voltage V0 is applied between its two ends, a current I flows in it. In addition, it is observed that the transverse voltage delta V develops between the inner and outer surfaces due to purely kinetic effects of moving electrons. Ignore any role of magnetic field due to the current. Then, so 4 options are given, and it's a very beautiful problem. So what happens here is, in this strip, as we are connecting this battery, then current starts flowing in this circular manner. Current in this starts flowing in this circular manner. So I can easily calculate the total current. So if you see in the option 1, total current has been calculated. So definitely V naught by effective resistance of this strip they are asking. So I'll be taking a ring of radius r and thickness dr, and this into the plane that thickness is t. So I can write dr is equal to rho L. L is the length along which current is flowing, that is pi r, divided by cross section area through which current is flowing, which is TDR. So if dr is coming in this denominator, or from here you can say all these currents are having different values, so it must be in parallel, because at the end potential differences are going to be same. So here I can write 1 by r effective as integral 1 by dr. When I simplify, I am getting r effective as pi root divided by t ln of r2 by r1, or current value I can write as v naught divided by r effective, which is going to give me option 1. Now if you look at these electrons which are traveling, because one more thing which is given here is that somehow this potential difference develops between the outer and inner surfaces. That happens mainly due to induced charges. Let's discuss how these induced charges are developing. So here, as electrons are moving along this circular path, so in order to give them that turn, there must be some centripetal force. So what happens exactly in this, the induced charges must develop in such a way that this electron can take turn, or this electric field must come in such a way that the FC is towards the center. So definitely we can say these red lines, you can see these are the electric field due to induced charges. So actually on the inner surfaces positive charge will develop, and on outer surfaces negative charge will develop. So from here I can say this centripetal force is nothing but mv square by r, where v is the velocity of electron, and that must be equal to small e into E induced, where E induced is the field due to these stationary charges, you can say, which is radially outward direction. So here we can say the if field lines are existing like this, the inner surface is at higher potential and outer surface is at lower potential. So outer surface will be at lower potential. B is the answer. A we have calculated. Now C is not the answer. So let's check this potential difference. So basically I have to check how much is the magnitude of this electric field. So what I'm going to do is I'm going to write this small current value, that is nothing but V naught divided by resistance of this strip, which we have calculated earlier. And that I value is nothing but NEAVD. VD is the drift velocity. I'm calling it here as VE. So when I substitute this value, cross section area of this strip is TDR. So through that, how much current is passing, I'm writing and equating those two values. When I do that, I'm going to get velocity of this electron as V naught divided by rho pi NER. Or from here you can say, if you substitute this VE value, you'll be getting induced electric field. When I do that, I am getting a very big expression here after substituting. But when you simplify, actually it comes as, I'm taking this big number as a constant, so I'll be getting this E induced as kV naught square by R cube. So potential difference directly I can write as R1 to R2 integral ER dr. So definitely it is going to be proportional to V naught square, because E is proportional to V naught square. So this is also an answer. So correct answer for this problem is going to be ACD. And my view of this problem, it's a very good conceptual problem as well as thought provoking, especially the potential difference part. And very few students would have solved it for all three options correctly. And in exam environment, it is really difficult to crack such type of problems easily. So it's a tough problem. Next one. Question number 12 as shown. So here what is happening, I'm not reading the entire question. So there is some solution here. KMnO4 solution is given, and there are different concentrations N1 and N2. Please be very careful about this. It's molecule per unit volume. Many people would have struggled with the molecule and number of moles per unit volume. So left side there are N1 molecules per unit volume, and right side there are N2 molecules per unit volume. When they are connected by a tube of small length L and cross section area A, KMnO4 starts to diffuse from left to the right. Consider the collection of molecules to behave as a dilute ideal gas and the difference in their partial pressures in the two vessels causing the diffusion. The speed v of the molecule is limited by the viscous force minus beta v on each molecule. Look at the language, it is on each molecule, where beta is a constant. Neglecting all terms of the order delta n whole square, which of the following is or are correct? So here this Kb is given as Boltzmann constant. So it's a very nice problem, very tricky also, and very difficult to crack in the exam. So here you can see, look at this tube. So from one side one pressure is there, from other side one pressure is there. So here we can say the force causing the molecules to move across the tube. So it is this pressure. So I can just simply write it as P1 into area minus P2 into area. And if you see here, PV is equal to nRT. We are asked to treat this KMnO4 solution as ideal gas. So if I use this logic, PV is equal to nRT, and this Boltzmann constant and gas constants are related as R by Na. So here I can write this as PV is equal to N into Na KT. So this is going to give me number of molecules. N is the number of moles. Here it is going to give me number of molecules. So very easily I can say here, if you bring this V downward also, this is going to give me number of molecules per unit volume. That is what we require. That is what is given in the problem as N1 and N2. So very easily I can say it is going to be NKT. So N1 KT into S minus N2 KT into S, or I can say N1 minus N2 KTS, which is answer number 1 is right answer. Another part is force balance implies, and one expression is given. So force balance means on each molecule, if you see, there is a force of beta V. There is a force of beta V. So this pressure difference force must be balanced by total viscous force. So N total into beta V is equal to F driving, which is causing the diffusion. So when I substitute the values here, it's a simple here. N1 into N1 is the concentration in the volume of A into L, and beta V is the viscous force. So this is going to be the total viscous force here. This N1 into SL is the total number of molecules present inside the tube. And just now we have calculated this expression of FD. So if we equate, we are going to get that answer. So from here you can check. Another part here, if you see, the rate of molecules getting transferred through the tube does not change with time, and total number of molecules going across the tube per second. So it is also the rate only. So C and D are related to each other. So let's check. Number of molecules crossing the tube per unit time. So N1 is this the concentration in the tube. VT is the length which it is going to cover in t seconds. Let's take t equal to 1. So that t is 1 actually, so it will become V into S. Now if I substitute these values here, I am substituting this value NVS. I am substituting this value from this expression. I am substituting this value from this expression here. When I bring it at this point, I am going to get N1 minus N2 KTS by beta L, which they have written in this form, delta N by L KT by beta into S. Alright, now if you see in this part, in the fourth part, this is fourth part is rate of molecules getting transferred through the tube does not change with time. So if you see, as time passes, the number of molecules are decreasing in left side, and they are increasing in right side, so n1 will be decreasing, n2 will be increasing, or delta n overall is decreasing. And if that happens, so that rate definitely will depend on delta n. It must be some function of time t. So here in the fourth option you can say rate of molecules getting transferred through the tube does not change with time. So it will be a wrong answer here. ABC is the right answer for this problem. And my remark about this is it's a very good conceptual problem, a challenging problem to solve in the exam environment. It's a difficult problem, no doubt. It's very difficult. Next problem. Here this is section 3, and it is again numerical type of question. +40 is the marking scheme. So here it is given, put a uniform meter scale horizontally on your extended index fingers with the left one at 0 and right one at 90. When you attempt to move both the fingers slowly towards the center, initially only one left finger slips with respect to the scale and the right finger does not. After some distance, the left finger stops and the right one starts slipping. Then the right finger stops at some distance XR from the center of the scale and the left one starts slipping. This happens because of difference in the frictional forces of the two fingers. If the coefficient of static and dynamic friction between the fingers are given as 0.4 and 0.32, then the value of XR in centimeter they are asking. Now again, this is a challenging problem. I'll say it's a pretty tough problem, especially when you read the question and try to get the idea of it. So here is the idea that when the rod is placed unsymmetrically here on these two fingers, so n1 and n2 different normals are going to act, and in this situation we can say n1 plus n2 is actually the weight mg of this rod. And here if you see, this arm length is more, and since it is in balancing about center of mass, we can balance the torque. So n1 into this distance and n2 into this distance. So from here I can easily say n1 is less than n2 in the beginning, or I can say if n1 is lesser, its maximum value of friction here also is going to be lesser. So when we start moving, this friction F1 is going to reach its maximum value first and sliding starts. That is what they are mentioning in the question, that the left part is sliding and this is at rest only. So F1 becomes kinetic in this situation, whereas F2 is still static. So this distance remains 40 and this distance becomes x. As time changes, we are bringing this finger closer and closer. At one point they are saying that here it will stop and this will start sliding towards the right. It will start sliding. So if again we are having same two relations here, this n1 plus m2 is mg, however I'm not using it. Another part is for the equilibrium of this bar or a scale, f1 must be equal to f2, and since it is not toppling, the torque also has to be equal. So n1 into x is equal to n2 into 40. This is one relation. Another relation is f1 is equal to f2. When sliding occurs, f1 becomes fk and f2 is still you can say it will be just equal to f1k, so that it can't move. So after the time slipping starts for the right finger, when this will start. So actually if you see what is going to happen in the beginning, when it will cross the same 40 point, what is going to happen in this case? n1 will be still less than n2. So it will cross somewhere here. Let's find this x value first. So here f2 is mu s into n2, and if I substitute these values, combining all these equations, I'll be getting mu k by mu s is equal to n2 by n1, and that should be equal to x by 40, and that is equal to mu k by mu s, which is 0.32 by 0.40. When I simplify, I get x equal to 32 centimeters. So you can see this is what I was talking about. The slipping starts at not at 40 but slightly this side because of normal. Now a reverse situation will occur. Now what is going to happen, the right finger is sliding and this one is stationary, so F1 becomes static, F2 becomes kinetic. So again same equations I'm going to use now. So this is the point XR where again the same process will be repeated. That means N2 becomes stationary and F2 becomes static and F1 will become again kinetic. So what is happening here, N1 into 32 torque balancing I'm doing, and N2 is XR. This length they are calling as XR. F1 is still equal to F2. When I simplify in similar to previous case, I am going to get this answer as 25.6 XR. Same thing we are doing and substituting the values. So correct answer for this problem is 25.6. It's a very good problem, needs conceptual clarity and understanding. Also, it takes time to process the problem after reading and analyzing. I feel it's a tough problem and very difficult to score full marks into this. For most of the people, there are people definitely they have done it properly. Next one. When water is filled carefully in a glass, one can fill up to a height h above the rim of the glass due to the surface tension of water. To calculate h just before water starts flowing, the model the shape of water as a disc of thickness h having cross section having semicircular edges as shown. When the pressure of water at the bottom of this disc exceeds, so here it exceeds, this pressure exceeds what can be balanced by surface tension, then water breaks near the sim and water start flowing. So if the density, all these values are given, so it's a very nice problem, slightly on the easier side but really good problem. So if you see the FBD of this extra part from the top, it is going to look like this point is here, this vertical line is this inner circle. So what we are going to do is, when I'm going to see the FBD of this extra part, so T into 2 pi r, this T into 2 pi r, and pressure at this topmost point is P naught, and this is relatively flat, so I can say here pressure is P naught plus rho gy. P naught is the outer atmospheric pressure force, so that is also acting on it. If we balance these forces, so I'll be getting direct answer here. So what I have done other than that is I am opening this part, so it is going to give me the rise of a rectangular strip having length of 2 pi r and vertical height as h. So all I need is I need to balance forces on this strip. Actually I'm writing these values as thrust. You can take a small sector here, and there also you could do the same analysis. However, in terms of magnitude, in terms of thrust, I'm writing it because once you open it and just cut it and open it, it will give you a diagram like this. So when I'm balancing it, one more thing I should remember, that this force is P naught A plus rho g YCM into A due to this changing pressure. You can use average pressure also, but I think those who are studying with me, they will remember these methods very quickly. When we solve it, rho g YCM into A term comes. So if we do that, force due to surface tension is T into 2 pi r, T into 2 pi r, and P naught into this area, this cross section area is 2 pi r h, and that must be balancing this hydrostatic force, which is going to be P naught into A is 2 pi r h, plus rho g YCM into A. So rho g YCM is h by 2 at the midpoint into area 2 pi r h. When I simplify this, I am going to get h as root of 40 by rho g. When I substitute the values, I am getting 5.29 into 10 to the power minus 3 meters. They are asking in millimeters, so answer is 5.29. A very good problem on surface tension. Normally students find it difficult on this topic, and it's challenging, but still I feel it's solvable problem for everyone who was prepared well for such type of questions. It's a tough problem, challenging problem, but solvable. The next problem, Question number 15. One end of a spring of negligible unstressed length and spring constant K is fixed at the origin. A point particle of mass m carrying a positive charge Q is attached at its other end. The entire system is kept on a smooth horizontal surface. When a point dipole P pointing towards the charge Q fixed at the origin, the spring gets stretched to the length L and attains a new equilibrium. And if point mass is now displaced slightly, then we have to find out the frequency of oscillation. So the first point to notice is that spring is having negligible natural length, that is length of the spring is the extension in the spring. And I have made one original problem on the same concept, shared it on the channel. So if you come across this, I'll be sharing its I button, you can click, or you can see in the description also, the elastic cord of negligible length. So such type of SHM motions are possible only if the string is having negligible natural length. So here it's a simple straightforward problem. So due to dipole, force acting on this will be Q into E. So at equilibrium I can write force field due to dipole into Q, that is equal to K delta X, which is L. So where K star is 1 by 4 pi epsilon naught. So this is the equilibrium condition, I'll be using it. Now when I displace it slightly by a distance of x, the spring force becomes Kx plus L, and this electric force slightly decreases. So overall it will bring this charge back to the original configuration. It will try. So F restoring is minus times net force towards the mean position. So Kx plus L minus K into 2p by new distance cube into Q. So when I use binomial approximation here for small oscillations, simplify it, I am getting this value. This is Kx plus 3k star 2p into Q by L cube into X by L. This value I can substitute from equilibrium position. When I do that, I simply get F restoring as minus 4kx. So when I'm getting minus 4kx, I can just write it as omega as root of 4k by m. You have to be very careful here. They are not asking angular frequency. They are asking about linear frequencies here. They are asking about linear frequencies. So 2 pi f naught is root 4k by m, or f naught comes as 1 by pi under root of k by m. So here this delta will become, you can see here they are asking 1 by delta. So here delta is pi, which is 3.14. So answer for this problem is 3.14. It's a very good problem, easier than other problems of the paper. It is a must solve problem. However, students can make a mistake while writing the answer of frequency and angular frequency, and it can be solved within the 3 minutes time frame, so or maybe lesser than that. So let me know in the comment section if you have made a mistake between frequency and angular frequency in your paper. Next problem here, question number 16. Consider 1 mole of helium gas enclosed in a container at initial pressure P1 and volume P1. It is expanding isothermally to volume 4V1. After this, gas expands adiabatically and its volume becomes 32V1. The work done by the gas during isothermal and adiabatic expansions are W iso and W adiabatic respectively. If the ratio W iso and W adiabatic is F ln2, then F is. So it's a simple problem, easy problem compared to the rest of the problems in this paper. So P1 V1 to condition isothermally becomes new pressure into 4V1. So definitely pressure is going to be P1 by 4. Now I can write work done in isothermal processes nRT naught ln V2 by V1. So nRT naught ln 4 or P1 V1. And this value also I can write as P1 V1 ln4. We'll see how we are getting work in adiabatic process. Accordingly, I'll be writing. So nRT ln4. Now this P1 by 4 to 4V1, we are changing it adiabatically to new pressure, and I'm making its volume as 32V1. It's a helium monatomic gas, so gamma is 5 by 3 here. So W adiabatic simply I can write as minus delta U or minus NCV T final minus T initial. So when I simplify, somehow if I get T final, I'll get the answer for this W adiabatic. So now I can use adiabatic process equation, which is TV to the power gamma minus 1. When I substitute these values and slightly simplify, I'll be getting T2 is equal to T by 4, when I do these values and when I get these values and do the substitution in the W adiabatic equation, I am getting this answer as 9 by 8 n RT naught. So here you can say the required ratio will come as 16 by 9 ln2, which comes as 1.777. They have asked us to write our answer up to 2, rounding off up to 2 decimal places. So I feel the answer will be 1.78. It could be 1.77 also, very difficult choice. So it's a moderate level must solve problem. Marks should be awarded to both the responses of 1.177 and 1.78. So let me know in the comment section, those who have faced this difficulty of choosing the right answer. Since they are telling us to round off up to 2, I feel 1.78 can be the possible answer. This is my view. It can be 1.77 also. It's a difficult choice. So towards the end, you will see questions are relatively on the easier side. And the next, a stationary tuning fork is in resonance with an air column in a pipe. If the tuning fork is moved with a speed of 2 meters per second in front of the open end of the pipe and parallel to it, the length of the pipe should be changed for the resonance to occur with the moving tuning fork. If the speed of sound in air is given, the smallest value of percentage change required in the length of the pipe. It's a very nice problem. So in case 1, this tube is here. For length L1, this resonance is happening. So tuning fork is having frequency of F0. So the received frequency here is also F0. So I can easily say that this must be equal to lambda by 4. So from here I know the lambda. So I can write V is equal to nu lambda. So F0 lambda 1, substitute this value, I am getting L1 is equal to, this is the length 1, which is V by 4 F0. Now when I'm moving this tuning fork, this is moving towards this with 2 meters per second square. So the frequency which is received by this pipe will change according to Doppler law. So the new frequency is F0 V by V minus Vs. So when I substitute here, and this value should be also equal to V by 4L2, similar to previous logic, where L2 is the new length for resonance to occur. So I got this L1, L2 value, and percentage change in length I can write just simply L1 minus L2 by L1. So it comes as 2 by 320, or the percentage wise it will come as 200 by 320, which comes as 0.62%. So it's a very good moderate level question, would be solved by majority of the students. The next one, a circular disk of radius r carries surface charge density of sigma r, sigma naught 1 minus r by r, where sigma naught is a constant and r is the distance from the center of the disk. Electric flux through the large spherical shape that encloses the charged disk completely is phi naught. The electric flux through another spherical surface of radius r by 4 and concentric with the disk is phi. The ratio of phi naught by phi is, it's a very straightforward question. Variable charge density is given. So when circle is larger, I can just simply say q by total charge by epsilon naught is my flux through sphere 1, which is phi naught. So up to radius r, total charge, whatever is present in the disk, that divided by epsilon naught. Similarly, this S2 is of radius r by 4. So its flux associated with this sphere will be QR by epsilon naught. So here somehow I have to find this QR. So I'll be taking a ring of thickness dr and radius r. So that will have a charge of sigma r 2 pi r dr. So if I integrate that, I'll be getting charge up to radius of small r, which comes here. So when I substitute the values of capital R and R by 4 and take the ratio, I am going to get this number as 32 by 5, which is 6.4. So it's a moderate level problem and must be solved in order to score in this paper. It's easy. It will be solved by majority of the students. So now I'll tell you about the overall difficulty level and my view of this paper. So summary wise, it's a difficult paper overall in my opinion. Certainly it is not easy to score in time bound exam conditions. And my personal assessment about this paper is a score of 20-22 marks can be obtained by a smart student in this paper in the given time frame, considering there are calculations involved, there are some heavy problems also. And I feel someone scoring above 45 marks in this paper is a potential top 100 all India rank as per my view of this paper. And I am expecting overall cutoff of JEE 2020 to be less than slightly on the lower side. It can be close to 30%, or it can go slightly less than that also in all three subjects combined, based on the review of all these papers. So I hope you have enjoyed this discussion. If it was fruitful and gave you some new insight, please share this with others. And if you haven't subscribed yet, please subscribe it. I'll be coming up very soon with the discussion of paper 2 as well. Please tune in. Thank you.